So our focus today is going to be on balancing equations. And what you'll notice is this is one of the equations that we did atom counting on yesterday. So if you remember this equation, it's lead nitrate and potassium bromide form lead bromide and potassium nitrate. So what we'll notice is different here are these coefficients that are out in front. And what we're going to find today is that we can add coefficients to equations to balance them. And we're going to get practice with that in this lesson. So let's go through and do our atom counting. So we're looking at our reactant side first. So these are our reactants. And if we look, we have one lead atom. And if we're thinking of nitrate, NO3, as one thing, we have two nitrate atoms, okay? And then we have a coefficient out in front. That coefficient goes to each part that's in front of it. So we have two potassium atoms and two bromine atoms. Okay, those are our reactants. Then we move over to our product side. And we see we still have one lead atom. We have two bromine atoms because it's Br2. Now we have this coefficient out in front again. So we're going to distribute that over. We have two potassium atoms. And we're thinking about NO3 as one thing, remember. So we only have two NO3s. It's not 6 because NO3 is one thing, so we don't need to multiply to that 3. It's just 2 NO3s. Okay, we can see now our number of atoms on the reactant side and the product side are equal to each other. So yes, this is balanced now. And like I said before, the way we achieved that is by adding coefficients out in front. And that's what we're going to practice doing today. So if we go down, we're going to look at this next part. This idea, it says blank in chemical reactions. The total mass of the products must be equal to the total mass of the reactants. What this idea is it is conservation of mass. So you want to fill that in there. This is our conservation of mass. And basically, the mass is a mass of one atom. So for a balanced equation, we must have equal numbers of each type of atoms on both sides. If we have equal numbers of atoms, we're going to have equal masses on both sides. Okay? This idea of balancing is to make sure that we have conservation of mass. Whatever mass we started with in the beginning is the mass we need to have after a chemical reaction has taken place, because we're not going to be destroying atoms in our chemical reaction. Okay? So if we go down a little bit further here, these are the 5 steps that we need to do in order to balance the equation. Step 1 is to determine the number of atoms on the reactant side. Then we determine the number of atoms on the product side. After we have done that, we want to balance elements one at a time using our coefficients. So we're going to start with one element and try to balance it, and then we'll move on to our next element. Step 4 is a key thing. We never, ever change our subscripts. The only thing we can do is add coefficients. Okay? And number 5 is just a good reminder. It is going to take trial and error before both sides are balanced. So you may need to try a few times before you actually get a balanced equation. And there may be points in time when you have to start over, especially with those more tricky equations. Okay? So let's look at a few examples down here. So we have example 1 and example 2 here. In example 1, we have H2, hydrogen, plus oxygen react to form H2O. Okay? So we start by counting the number of atoms in our reactant side. We have 2 hydrogen and we have 2 oxygen. Those are both diatomic, so they show up as H2 and O2. Then we count it over here. We have 2 hydrogen atoms and only 1 oxygen atom. Okay? So we're not balanced right now. So we pick an element that's unbalanced and we go and try to add coefficients to balance it. So right now what we're going to notice is our oxygens are unbalanced. In our reactant side, so these are our reactants. Remember, those are what happened before we have a chemical equation. And then our products are what's produced after the chemical equation. So for our reactants, we have 2 oxygens and we're only left with 1 oxygen in our products. So we can only add coefficients out in front. So I'm going to add a 2 out in front here so that I can get those 2 oxygens. But what that's also going to change is our hydrogens. So this distributes over and now we have 4 hydrogens and 2 oxygens. So now our oxygens are balanced. We have to balance our hydrogens. So I'm going to add a coefficient out in front of here to balance my hydrogens. So this becomes 4 hydrogens now. Now I can double check. In my reactants, I have 4 hydrogens, 2 oxygens. In my products, I have 4 hydrogens, 2 oxygens. So I'm balanced and I'm done with balancing this chemical equation. Okay, for the next one, we're doing something similar, okay? So what we're doing is, let me get this off the screen there. There we go. What we're doing is we're balancing the equation again. So we have CH4 plus O2 goes to CO2 and H2O. So I start, let me scroll down a little bit so I have, I'll move this in the middle. So I have a little bit more room down there. Okay, so I start with just writing how many atoms of each I have. So I have 1 carbon, I have 4 hydrogens, and I have 2 oxygen for my reactants. And then I have 1 carbon. Here I have 2 hydrogens, and we can see that oxygen is split. So remember, we have to add those together. So we have 2 here plus 1 oxygen. We have 3 of them. Okay? We are not balanced. So what I like to start with is if I have an odd number, it's way easier to balance if we can do it with even numbers. So I try to make this even. So here I have 2 oxygens. This oxygen is the one that's making it odd. So I'm going to add a 2 out in front of here. And that's going to help me balance my oxygens and make it an even number. So 2 oxygens there and 2 oxygens there makes this 4 oxygens, and 2 H2 makes this 4 hydrogens. Now we can see my hydrogens are balanced, but my oxygens are still not balanced. So what I'm going to do is add a 2 out in front here, and that's going to give me 4 hydrogens. Now I have 1 carbon, 4 hydrogens, 4 oxygens in my reactants, and I have 1 carbon, 4 hydrogens, 4 oxygens in my products. And we are balanced. Okay? So take a look at how I did both of those. The goal is to get the same number of atoms on one side as the other side. Once you're finished with balancing those ones, we're going to come over here and you have a bunch of examples on this page to practice. What I would recommend doing is splitting this in half here and writing my P and O and writing the numbers there, and then P and O over here so you can write the number of atoms and that'll help you balance. Doing the same thing over here. We have Na, H, and this one you could do NaH, and we can keep hydroxide as OH. And you're counting the number of atoms Na, H, and OH. Okay, I would just recommend doing that so you can have a place to count your atoms as well, just like what we did on the last page. So practicing these ones on your own.